Good afternoon. We're going to be talking about the homework tonight, complex polynomials and factoring. You got a nice taste of this probably throughout last week as we were reviewing for the EOC, as well as this week. Some of the problems that we had to do required you to be able to understand how factoring works. And not just when they're perfect squares, but also when they're more perfect cubes. And so just really giving us a feel for what that should look like. Here's some of the more complex factor problems that you may need to be aware of. This problem right here is very similar to a difference in perfect squares. So if I'm trying to think of what two things would multiply to be 16, specifically negative 16, I start thinking about 4 and negative 4 pretty quickly. There's a lot of cancellations in this one because I don't have like a middle value or a middle term in which they add to be during the multiplication process of this binomial. But what multiplies to be x to the fourth would have to be x squared and x squared. So that kind of eliminates D pretty quickly, which I'd cut off in the problem. C is pretty tempting because that's exactly what I just came up with. The first one really looks bad. I mean, 10 times negative 20 is like negative 200, so I'm thinking that one's probably out as well. But you want to be careful because sometimes things can further factor. For example, you can't do anything with this one. This one's kind of stuck, but this one can kind of do it again. This can do that same difference in perfect squares. Square root of 4 is 2. And so if you had 2 and negative 2, then that would also work. So this one is B, okay? And I tried to help you out because in C I made it x minus 4 instead of x squared minus 4 to really make you think, there's something else about to happen here, and that's why you got to factor it again. Okay? Number 2, so this is very similar to what we were doing in Algebra 1, like difference in perfect squares, except now the power is up. We're not just factoring a quadratic, we're factoring a quartic when it's the power of 4. So it's still very similar. Like what multiplies to be 56 would be 8 times 7. And I really want a positive one when they subtract or add. So I'm going to say that's positive 8 and negative 7. But the way that I get the powers to work here is they're not just 1 and 1. I really need 2 and 2, very similar to what I did over here. Now, if 7 was a perfect square, I would really try to consider what's left in terms of breaking it up in difference in perfect squares. But this one's kind of done. You can't do anything with that. Just like when I got to here, I couldn't do anything there either. So just real quick, just to see how it works, u times u is u, but the 2's are adding to be 4. Multiply the next one, you get negative 7u squared. Multiply these, you get a positive 8u squared, and that's where we're getting a positive u squared from the problem. And then the very last part is your negative 56. Okay? Just to kind of think about how could you check your answer, multiply them all together. So we talked a little bit about grouping yesterday, or today really. And so I'm going to do a multiple choice problem with you, and then I want you to do 4 for your homework. Okay, that's your problem to do. So what we have is we have 3a to the third minus a squared. It looks like they both have a squared in it. So if I divide each part by a squared, that 3 is still there as a coefficient, but 3 minus 2, there's still an a in there. And if I divide a squared by a squared, I just need the sign that makes that happen, negative 1. So a squared times 3a squared times negative 1. If you distribute this, you'd be right back to where you started. Okay? So now I want to really look at this second part, negative 21a plus 7. Both of these are divisible by 7, but I want the signs to work out so that this parentheses repeats. So I'll look back and the signs went positive, negative, and then they kind of reversed and went negative, positive. So that tells me that I have to take out a negative 7 in order for this next part to really repeat 3a minus 1. So negative 21 divided by negative 7, that's positive 3. And 7 divides by negative 7 to make negative 1. So there's your 3a minus 1. That seems to be repeating. And then the other part is a squared minus 7. And this can be written in either order, and so that's why C is the correct answer. So on your homework question number 4, I want you to look at what could come out of the first two and what could come out of the second two in terms of group factoring. And if you have a question, just email me or let me know through Twitter or whatever social media you follow me on, and I'd be happy to support you on that if you have any questions. A lot of the problems that we talked about today were complex. That's going back to one of the very first chapters in Algebra 2. And so we have to understand that when you multiply these together or when you add or subtract, we've got to really knock down that form of A plus BI. Okay? A is your real number and B is your imaginary number, and that's where all of your answers kind of simplify to. So let's talk about the first one. This is against each other. There's nothing in between those two parentheses. They're butted up right next to each other. So that tells us that we have to distribute or multiply. So we're going to do 3 times -1. That's -3. We're then going to multiply 3 times 6i, 18i. We're then going to multiply the 7i to both parts, and really it's negative, so -7i times -1, that's a positive 7i. And then our very last part is -7i times positive 6i. So there's two things here. -7 times 6 is -42, but now you have I times I, and that is I squared. There's a pretty good chance you could get this on a non-calculator exam, and so we really want to know what is I, okay? So I is this idea of the square root of -1, okay? And it probably won't let me show you that unless I'm in the correct mode. So right now I'm in the real mode. If I switch that over to A plus BI mode, it may show me that that's actually the square root of -1. Or maybe I can square root -1 and it would tell me that it's I. There it is. Okay? But what happens if I squared that? What if I said, okay, I've got I, but it's squared, and that's where you get the value -1. So that very last is -42I squared. So essentially, this is -42 times -1. And so those signs are going to change and ultimately add 42. Okay? And you're going to add that to this number, -3. So I'm not changing the operation like, oh, I need to put them together, so do the opposite. It's this value is 42. If you were to put in what is -42I squared, it's going to tell you that that comes out to be a positive 42. So now I need to put that together with the other number, 42, added to -3, should be 39. And if you put 18 plus 7i together, those are like terms, there's where you're getting the 25 from. So that should be 39 plus 25i. That should be B. Okay? So let's walk through another one. I do expect that to be something you'll need to know. So let's talk about it. 5 times 4, 20. 5 times 5i, 25i. -2i times 4, -8i. -2i times positive 5i, -10i squared. But again, this I squared, this value is really the value -1. And if that -10 and -1 are multiplying, it's like at the very end, I have positive 10. So just to not be lazy, I want everybody to see that number is just changing to be 10. Okay? So 20 plus 10 is 30. And the middle, 25i minus 8i, 25 minus 8 is 17i. 30 plus 17i. So those are a little bit harder. I think these next ones are kind of simpler. We just need to put them together based on the sign in the middle. So I've got a 1. I'm adding 5. That's 6. Problem. -8i plus -8i. Careful, it's not 0. It's -16. So again, kind of going back to what I was talking about, all of your answers take on this a plus bi answer form. A is 6, b is negative 16. Or in this one, a is 30, 17 is your b. Okay? Same thing for all of our answers. They all take on that form of a real number added to an imaginary number. So this one is subtraction, and I'm going to let you guys try this one on your own, and we'll check your work tomorrow in class. Two problems here that have us dividing. So we have what's called long division and synthetic division. So I'm going to show synthetic division for number 9, and for number 10 I'm going to show long division for number 10, because you may have to do both. So if you're doing synthetic division, what we're going to do is we're going to take all of the coefficients like 1, negative 19, 91, and negative 5, and use the 0 of what you're dividing. So what makes this parentheses 0 is 9. 9 minus 9 is 0. That would be a perfect factor. So I'm going to use 9 in the synthetic division process. So we need to drop the first value and then multiply. 9 times 1 is 9. Now the reason you drop that first value is because technically you're adding, but there's nothing here. So we're adding 1 with 0 to get 1. So let's keep adding. If you add these, you get a negative 10. Let's multiply 9 times negative 10. That's negative 90. We add these together and you get 1. We multiply again, 9 times 1, that's 9. And because this is the last number, this represents our remainder, and that gives us positive 4. So the answer to this, if it was n to the third, and you divide it by n, just like power rules, if you're dividing n to the third by n, they subtract to give you n squared. So that is why you're going to change all of your coefficients down here to be like 1n squared minus 10n plus 1, and then because I have a remainder, I'm going to say it's plus 4 back over what I'm dividing, which is n minus 1. And this is the final answer. So what I'm going to do is I'm going to demonstrate that with long division. Okay? So instead of using synthetic division, I'm going to try this one using long division. Instead of synthetic division, I'm going to use long division. Okay? 20k to the third plus 66k squared plus 25k minus 9. So how many times does 20 divide by 5? I need a 4. And there's 3 k's there and only 1 here, so I need 2. So I'm going to multiply 4k squared by 5k squared, 20k to the third. 4k squared times 4 is 16k squared. And then I'm going to subtract each of these numbers. These kind of cancel. 66 minus 16 is 50k squared. Drop the next term, 25k, and start the process over. 5 goes into 50 10 times. But I only have 1k and I need 2, so I better have an extra k on that. Multiply together, 10k times 5k, 50k squared. 10k times 4, 40k. But again, we are subtracting each of these values. The first one cancels. 25 minus 40 is negative 15k. Drop the negative 9. Last time, 5 goes into negative 15, negative 3 times, and the k's are actually correct. I don't need to put an extra one there. So negative 3 times 5 is negative 15k. Negative 3 times 4 is negative 12. But again, we're subtracting. So if you're minus and a minus, that's ultimately making this a plus. Same thing for the other one. Minus a minus makes a plus. These cancel out, and you end up with 3. So your final answer is 4k squared plus 10k minus 3. And then the 3 that you got at the end is going back over what you divided by, 5k plus 4. So there's your long division. I think I'm going to get caught here by the bell. So good luck. I'll